What is up, people? Fahir here from AwesomeTuts.com, and so far, or moving forward with our object-oriented programming principles. So far we have covered classes, we have covered objects, we know how we can use these functions, and we know what data encapsulation is. And I want to talk about an important concept, which is called inheritance. Now, what is inheritance? Well, it is in fact what you think it is, but you're not like gonna inherit money from your granddad. It's not like that, but it is like you inherited your, I don't know, hair color from your granddad, maybe strength. Your grandfather was a strong guy, so you inherited that kind of inheritance. So let's talk about it. I usually, when I talk about this, I like to bring in game development, and since this is game development, well, there is no better explanation or there is no better example to take than game development. So let's assume we are making a game where we are going to have three characters. One is going to be a wizard, a knight, and an archer. So we have three characters that we can select. Now we are going to model those characters in a class. Let's say all of these three characters have some default behavior, which of course is the case, such as health. So every single character is gonna have health. Every single character is gonna have name, maybe power, and something like that. So we determine what their default or their common behavior, so their shared behavior, what they gonna have. And we're gonna model that in the player class, as we did right here. So we have a private float health, and we have here a getter and a setter for it. We have a private string name, and we have a getter and a setter for it. And these properties, so the health and the name, is something that all three players are gonna have in the game. And they're also gonna have this public void attack, and they are also gonna have this player info where we are gonna get the player info from them. So this is how we model that default or that common behavior for all three of them. But now we want to implement one separate character. We can do that. We can go here in Unity, and I'm gonna go in the project, and here enter to C#, right click, create a new C# script, and we are gonna create a wizard. I'm gonna hit enter, and I am gonna double tap on it to open it. Let me quickly tag the class here with a comment, hold enter to give a little bit space so that we can see what we are typing. Now this right here, we don't need it, so delete it right away, and we also don't need this. So what is actually, or how can we denote that we are inheriting from the player class? Well, we just saw it. We just deleted it here. So we type this colon, but instead of mono behavior, because previously it was mono behavior here, now we need to type player because we want to inherit the player class, which is this class right here. So as I said, this means that you are inheriting some properties such as the hair color, the strength. In this case, you are gonna inherit these properties. So you are gonna inherit this health variable. You are gonna inherit this name variable. Also, you're gonna inherit these functions. Now, what do I mean by that? Well, I mean that we can go in our tester class right here, and in the start function, I can type wizard. W is equal to new wizard. Now, we don't need to declare, so wizard. We know that we don't need to declare here a constructor if we don't declare a constructor that has arguments, such as here. So if you only want to have a no argument constructor, you can declare it like this. We can do here public wizard. So we can say public wizard like this. And we can declare it, but we don't need to because we can have it automatically. Going back to our topic, so I said that we are also going to inherit these functions. Now, again, maybe you're confused. Let's break that confusion. So now I can type wizard or v.attack. If I go here in Unity and in the console and I hit run to run my game, we are going to see in the console, let's just wait for it, the player is attacking. If I double tap on it, it is going to bring me right here in the player class. Now you're like, whoa, are you a magician, teacher? What is going on here? Or are you just crazy? Nor I'm not a magician, nor am I crazy, but as I said, we have inherited from the player class, meaning that we are also inheriting these properties right here. So we have health, we have name, we have attack, and we have the player info because we are now inheriting from the player class. The player class in this case is called the parent class, and the class that is inheriting it is called a child class. So the class that is being inherited is a parent class, and the class that is inheriting it is a child class. So in this case, player acts like a father or a parent to the wizard, and we can access all of these properties. We can even use the player info. So instead of attack, I'm going to say W player info, and notice what is going to happen when I go in Unity and run it. We are going to see that the name is default and player's health is 100. Why is that? Well, because we have declared it here in the player class. So health is 100 and the name I put to be default. We can change it because we can access these public properties now because, well, we have declared them in the player class, and I can go here above, and actually I'm going to do it below. I'm going to leave this right here and I'm going to do it like this. I'm going to say w.name is now equal to wizard. So wizard, and w.health is now equal to, let's say, 13.4.5 actually. And I can print that out also. So I can print it out, but I want to separate them. So I'm going to use print, and I am going to pass here \n. So what do you think is going to happen now? And the fact that we can use w.name from the wizard to change the property and health in order to change the property is what we call inheritance. So let me clear the console quickly, run it, not actually pause it, but run it again. Notice here, the player name is default and player's health is 100. And here we have, well, I did not put this correctly, but it does not matter. Player name is wizard and player's health is 13.5. This is what inheritance is. So you model, actually we need to put it like this. So you model the default behavior. So as I said, every single player, the wizard, the knight, and the archer are gonna have health. They're gonna have name in the game. They are gonna be able to, or we need to be able to get those properties because we need to, well, manipulate them. When we fight an enemy and he touches us, then we lose health. And also we can have here public void player info because in our game, we want to get the info when we encounter that player. So this is their default behavior, and every single one of those characters can attack. So we model all of that in this parent class as a default behavior, but now when we create a child class, we can develop child class further on. What does that mean? That means that, for example, wizard will have mana, which is only specifically Titan, however you want to call it, or connected to the wizard. So here I can have a private float mana, which is equal to 33F by default. And you know, in those games, when you have a wizard, he needs some mana in order to perform an attack. And that is only connected to the wizard. It is not connected to the knight because knight does not need mana. He strikes with his sword. The archer, he throws arrows. He does not need mana. But for example, for the archer, he will have, well, his arrows. So we'll have arrows, which is not tied or connected to the wizard. So the specific behavior for that particular player, you now implement inside of his own class. But the overall behavior, their default behavior, their shared or common behavior that all of them are going to have, you can model like this in your parent class. And now we can go here, we can create public void get or replenish mana so that we get more mana, and we can say something like this, float mana, and here we can say this dot mana is equal to mana, which will allow us to replenish mana. And if I go here and I type w.replenish mana, notice now I can pass here 33F and we will replenish mana. But what will happen if I have here, if I have player P is equal to new player, not playing, but player like this, I cannot go here and I cannot say P dot replenish mana. This will not work. Why? Because we did not declare that in the player class. So inheritance goes downwards. What does that mean? It means that the class that is inheriting will also inherit all of the properties, but the inherited class, which in this case is a player, so the class that is being inherited, this one, has no idea about everything that we type here in the wizard class. The player class does not know that we have this public void replenish mana, nor does it know that we have this private float mana. Now, also what I want to talk about is that private variables will not be accessible inside of the child class. So if I go here and I create a private float power, which is equal to 100F, this private variable is not accessible inside of the wizard class. We can even access all of these variables, these public ones. So these right here, public health and name. We can go here and we can type. So I can say public wizard that takes a string name, comma, string health. Actually, it's float health. And I can say this dot name is equal to name, and this dot health is equal to health. Why can we do this? Well, we are inheriting name, which is this right here. We are inheriting that, and we are inheriting health. And this is totally legit. I can go here, and instead of typing here the name wizard and whatnot, I can simply type here in the constructor now. So I can say wizard, comma, and I can say 34.123F for the health. And this can work. I can say w.playerinfo. Notice that the name is going to be wizard and the health is going to be 34.123. If I hit the run button, notice player name is wizard and player's health is 34 and 123. But notice now I have declared this. So I have declared private float power. I cannot access it here. I cannot say power is equal to, I don't know, 123F. Notice it is not allowing us to do that. And if I go back here in Unity, notice player power is inaccessible due to its protection level. If I double click on it and right here, it is aware that we have the power variable declared here in the player class, but it is not allowing us to access it because it is set to private. If, however, we set it to be public, so if we set it to be public, so not public, it's public float, now I can say power is equal to 23F. And this is totally legit. If I go back now, notice the error is going to go away. We don't have any errors. I can clear the console. We are good to go. But if you want to do something like this, you're not going to do it again like this. So you're going to leave this one to be private, and then you will create these getters and setters either as variables like this, and then type, well, get and set, or create a function. So you can create a function like public void get power, and then you know the drill as we did in our video about data encapsulation. Now, also I want to talk about one thing, and that is, notice this public virtual void attack. So I'm going to remove this virtual at the moment. So only we have public void attack. What does this mean? Well, this is a function that we have implemented in our player because all three of our characters can attack. But notice one problem that we have. We can go here and we can call the wizard. So we can call on the wizard attack. So I can say here attack, and this can work. I'm going to go here in Unity. I am going to hit run, and here it is. Player is attacking. So everything so far is okay. And you're like, well, what's the problem? Well, this is their common behavior. So every single player can attack. The wizard can attack, the knight can attack, and the archer can attack. But all three of them attack on a different way. Wizard is going to throw a fireball. The archer is going to throw arrows at you. And the knight is going to strike you with his sword. So what we need to do? Well, we have the common behavior, which is this one, defined here in the parent class. But we need to implement it in our child class in order to, well, make it appropriate for the child class. Let's assume that the default attack is going to be freezing an enemy. So attack, and I'm going to say colon, enemy is frozen. So enemy is frozen. That means that when we are attacked with an enemy and we use this default attack, he will be frozen in front of us. But our wizard, he throws fireballs. How can we implement that? Well, for that, we need to type here public virtual void that you just saw in a moment. So public virtual void attack. And then here we can go and type public override void attack like this. And what is going to happen now is the following. I'm first going to comment it out, and I'm going to go in the tester class because we still did not override it. We are going to print this to the console and see the behavior. So I'm going to go here and I am going to simply clear the console and I'm going to run it now. Notice enemy is frozen. So attack, enemy is frozen. This is what we see when we call, here W attack, which is our actually wizard attack. But notice now what is going to happen when I use public override void attack. So I'm going to say here print, or actually debug.log, and I'm going to say here wizard attacking, throwing a fireball. So this is going to denote that the wizard is attacking and that we are throwing a fireball. And let me just quickly delete this float power because, well, we don't need it. And I'm just deleting it so that we don't get any warnings in our console, because I want only to display the attack or the property from the attack function, what is being printed to the console. Previously, we saw that we debug.logged attack enemy is frozen, which you can see right here in the console. But what is gonna happen now, and I forgot to delete mana, no biggie, but what is gonna happen now since we used public override void attack, which is the same signature, so here is the same signature, attack is here and attack is in the child class, but now we are using debug.log wizard attacking. Let's check it out and see. So when I hit run, notice wizard attacking, throwing a fireball. This is called overriding functions. So overriding functions means that we don't want this default behavior. So this common behavior across all three of our characters, because this default behavior will freeze an enemy which is in front of us. But the wizard, he is throwing a fireball. The knight, he is attacking with his sword. And the archer, he is throwing arrows at you. So we need to type public override and the name of that function, same signature. When I say signature, it means that the function, if it's defined in the parent class to be public, it also needs to be public in the child class. If the function does not return anything denoted by void, also here needs to be void. If the function is not taking any parameters, then also here it does not take any parameters. If, however, it is defined to be like int, so it returns an integer, then you will need to define it that way. The same way as you have defined it here in your parent class, you define it right here. But the implementation or the code that is inside of that function will be different for your child class. In this case, wizard is attacking by throwing a fireball, but the default attack is we are freezing an enemy. And also the function that you want to override in the child class, you need to mark as virtual in the parent class. So if we remove this virtual from the parent, notice what is going to happen now. We see here that wizard attack cannot override inherited member attack because it is not marked virtual, abstract, or override. So mark it here to be virtual if you want to implement a separate behavior for the same functionality. Now, don't be confused about this because I saw some students that had some issues with this, and this is the same functionality. So we are attacking with the player, we are attacking with the wizard. But notice here the attack has enemy is frozen. But here, the attack has throwing a fireball. Now, just imagine that this code is going to create, or it is going to freeze the enemy in the game, and this code is going to throw a fireball in, well, our code. Now, this was the basics of inheritance. And why is this important? Well, let me show you. If we go into Pumpkin class, notice here, we can access the awake function. We can access the start. We can access the update and the fixed update. We got all that from mono behavior. Notice here, I can also use this transform.position, but I did not define transform position anywhere here in the class. Notice if I remove that we are inheriting from mono behavior, automatically this is not accessible. This right here is not accessible because we are inheriting that from mono behavior. We can use get component to get attached components on our game objects. We can also use the property game object, which is, well, the property from mono behavior. So this is why it is important. And you also maybe have wondered, how did I get this on trigger enter? What is this? Well, on trigger enter is also inherited from mono behavior. So we have already, when we start our game, when we create a function, we already have some predefined values that we can use right away, such as the transform property, the get component, the game object property, and the on trigger enter, and other functions like on collision enter, so on and so forth, which we'll cover that later, don't worry. But my point is that when we inherit here from mono behavior, we are getting all of those functions and properties, and we have that functionality already built in our class. We only then implement our own logic to make our game going. So this is why it is important for us to understand what is going on. And same way when you start building your own games, maybe, well, you want to create a game like this, as I already explained. So you create 3 players, they have some common behavior that you're gonna define in the parent class. And from then on, you are gonna, well, expand the child class further on to implement the specific variables and specific functions for that child class. And this is a good way to program, and this is how you are gonna program if you work somewhere or if you get a job in the game industry. This is how you will be asked to program. So I don't want to stall anymore. This is probably more than 20 minutes. This was about inheritance. Fahir here from AwesomeTudes.com, and catch you guys in the next video.